Well, good afternoon, Saquib. How are you?
Hey, Richard. Great to be here.
I'm so excited to have you here today, and welcome to Rare Awareness Radio. And we are speaking with Dr. Saquib Lakhani. And I'm going to ask you to kind of maybe take a few minutes to introduce yourself. I mean, you are a pediatric critical care physician, but you're so much more than that. So I would love for you to just kind of two minutes on yourself and just familiarize yourself with the audience. That would be super.
Yeah, sure. Yeah, as you mentioned, really, I'm a pediatric critical care physician, and that's where I see myself, and where a lot of this journey has started for me. So, we take care of kids in the ICU. So that's from birth to roughly 18 years of age who are sick with any of, trauma,
any affliction, right?
Yeah, anything that puts them in an ICU, we care for them. And it's an interesting thing, and this has been my my clinical love is taking care of children and their families in the ICU, because it really is more than just the child. And for many years, as we practice medicine, we see children in pediatrics who have a lot of underlying medical conditions, and sometimes they present with things like, congenital heart disease. So they have heart malformations or brain malformations, or they have unusual conditions. Maybe in the ICU, they present with looks like sepsis or bad infection, but we can't really figure out, there's no bacteria that's been involved. And for many years, we've thought that, hey, these kids must have something underlying. And then we just kind of shrug and say, well, there's nothing we can really do. We just move along and try to do the best that we can.
Right, sure. And with the information you have, and
with the information that we have. And yet, within, roughly the last decade, the advent and widespread use of genomic sequencing has completely been a game changer. And what we've been able to do for many of these patients is to say, hey, you know what? This kid might have something, and we might have a tool to help figure this out.
Right.
And that's how really where the interest drives for us as clinicians in the rare disease space is understanding, why do these kids have this problem? And we're very used in medicine to just putting on what we call descriptive, or what I call descriptive diagnoses, right? And we consider that a diagnosis. So we might say, this kid has transposition of the great arteries. And we figure that's because the aorta and the pulmonary artery are switched, and the child needs surgery, otherwise they'll die. And we consider that a diagnosis, but that's not a real diagnosis. That's just a description of their problem,
of their condition.
It doesn't tell you anything about what caused it.
Right.
And same things. There's things like Lennox-Gastaut or West syndrome, and so basically means bad seizures, right?
Yeah.
And we wouldn't accept that as a diagnosis in most places, but for years we're being conditioned to, because we don't really have a choice. But now we've been able to, and so what my group focuses on is how can we turn these description diagnoses into actual molecular diagnoses, and from molecular diagnoses, how can we move on to more targeted therapies? How can we move on to even if we can't provide therapy, can we provide information and details to the families that are helpful?
It's interesting what you said there about kind of targeting it at a molecular level, right, Saquib, and trying to get to what really could be the personalized or prescriptive approach to this, right?
Yeah, absolutely. And some of the conditions we find, for instance, that they might respond better based on what that molecular diagnosis is. They might respond better to different types of therapy. Seizures is an example. We're going to talk about CRELD,
in a minute,
CRELD1 today, and a big component of the children who have that condition is seizures. And sometimes, if we can understand how those seizures are, what is the underlying molecular mechanism of those seizures, we can perhaps decide that, hey, these kinds of therapies are more likely to be successful in patients who have these variants, as opposed to other types of therapies.
Wow. So you are the director of the early detection program at Cedars-Sinai Guerin Children's, and you kind of talked for a second there about early detection and what advancements you've been able to make in early detection. But talk to me a little bit about your role as the director, and sort of what do you focus on as part of the early detection program? I'm sure it's part of the name, but more specifically.
Yeah, absolutely. And we're still building this program. This is sort of an extension of work that I've done over the past decade at Yale with our rare disease program there. But really the idea that we're building is a a program that will allow for early detection of these types of conditions, because many of these, and I'm sure if there's parents and families out there, they'll many of them will empathize with the diagnostic odyssey, right?
Oh yeah, we've talked so much about that on this show. Yeah.
Yeah, right. There's so much wandering around trying to figure things out. And if we can institute a program where we can begin diagnoses at an early age, perhaps even, and we're considering approaches like newborn screening. So can use newborn screen, and people have thought about, and newborn screening happens now. It's a biochemical test, and we look for certain genetic diseases that are that you can intervene on. But can we expand that? Can we not just look for, because these are chosen, for instance, hey, you give particular medications, or you would avoid particular types of foods, or you do particular interventions if you know these diagnoses. But there's so many other diagnoses, thousands literally, that we can potentially start picking up, and we can give answers to families and avoid some of these diagnostic odysseys. So that's what we'd like to do. That's our goal. We're still in the implementation stage, in the development stage, but we're hoping very quickly to start, beginning these early diagnostics with pediatric patients who sort of present with rare disease, but then moving on to early diagnoses even before they present.
And to your point about the diagnostic odyssey, what an amazing advancement that would be, right, for these families, like you said, and the technologies that you have to help improve early diagnoses, genomic sequencing, et cetera. That's really outstanding. As you think about what initially drew you to CRELD1, and I mentioned to you earlier that we had Adam Clatworthy on the show, and he talked to us about his work and kind of beginning with the CRELD1 Warrior Foundation, and it's a very personal story for Adam, as you know. But I'm curious as to kind of where you started to think about CRELD1 and what specifically drew you to it. I know you've done a lot in different areas, congenital heart defects you mentioned at the beginning of the call. So where did that kind of come first into focus for you?
Well, as it happens, it was just a chance.
Really? Yeah.
So we were caring in the I still practice pediatric critical care, and we were caring for this child in our ICU who, it was one of these children that we'd look at and we'd say, hey, she's had a lifetime of seizures, but she started out, relatively healthy, was looking good, and then had onset of seizures and things deteriorated. We had taken care of her in the ICU for, several times. And I spoke to her parents and I said, hey, listen, you know what? I suspect she has something underlying, but, perhaps it could help us in how we manage her, or at the very least, maybe we can give you some answers.
Right.
And so we did some DNA sequencing, and we did not find a clinical diagnosis for her. However, we found a couple of variants in this gene called CRELD1.
Yeah.
And, nobody had really sort of looked at it to this level. It hadn't been described before. And we started thinking, hey, is there something that, something here?
Right.
And can we make a diagnosis? And then from there, this is, one of the powers of communication. We worked with, GeneDx, which is a genetic testing company. We worked with, they helped us get in touch with several groups, including at NIH, some groups in the UK, around the US as well too. And we identified multiple patients who also had CRELD1 variants. And so at that point, we're like, hey, yeah, this is
something to this
pattern. And then many of them fit a similar clinical description. And then we said, hey, we just need to provide some additional basic science evidence along with this. And then we took it to the lab and worked in our frog model, and analyzed the protein itself, and at least found enough evidence to say, yeah, this is the case.
I wanted to ask you about some of the common symptoms or manifestations in children with CRELD1. You just touched on that for a moment, right, where you were kind of seeing some commonality. I worked for a number of years in heart rhythm disorders and kind of really understand the need for the basic science there, like you mentioned, to kind of do that important work. But when you are, as a parent, let's say, are there common symptoms or manifestations in children that are specifically CRELD1 related to the CRELD1 related conditions?
Yeah, I'd say that really the big one is probably seizures,
Hmm.
and it can be varying, and it really depends on the actual individual variants that the patients have.
Mm.
We're seeing some across the spectrum that are relatively mild, but many of them do have pretty severe seizures.
Yeah,
Another very common one is the developmental delay as
sure.
well, and whether that's uh, it's always hard to say, hey, is it because of the seizures or is it independent?
Mm.
There may be some combination because many of these children start out, developing fine, and then when the seizure onset happens, that's when the developmental delay gets significantly worse, and they
Yeah.
often regress. And ones who have milder variants seem to don't have as much developmental delay. So that
Mm.
and not as much seizures as well too. So that would seem to possibly be the case,
Yeah.
but still, there's a
Learn.
lot to learn. The other interesting and still puzzling aspect of this is the cardiac rhythm disturbances
Really?
that have several of these children have. And we don't quite have an etiology for that. The previous work that was done with CRELD1 was actually the first gene to be identified as associated with septal defects in the heart. So
Oh,
these
really? Okay. Huh.
structural heart defects. And we saw a few patients, but only a couple in our whole cohort. But more than roughly half of them actually had cardiac rhythm disturbances.
Hmm.
And it seems that we've heard about additional patients as well who might have those issues too. So a lot still to learn. And
Yeah.
and I'll emphasize, actually, I'll make a couple of points here. One is, you're talking to me, and we were the primary, our group is the primary author on this paper, but it
Right.
really there were so many contributors from around the world that made this possible.
Yeah.
And really what we established was, yes, CRELD1 is associated with this particular disease and condition.
Right.
However, there's so much more work that
Needs to be done.
smart people that are going to be working on.
Yeah. And to that point, let's talk about, from the need for more work to be done and how that kind of manifests on the families and how they're kind of faced with the different types of challenges when a child is diagnosed with CRELD1 related disorder, and how do you and your team kind of support those families and work with them as part of your sort of approach?
Yeah, I think there are multiple aspects to that. One is simply getting that diagnosis,
Hmm.
and there's an answer. And what goes hand in hand with that is community.
Yeah.
And we are a part of that community,
Right.
but we are by no means all of that community.
Right.
I think the families, like mentioned Adam setting up CRELD1 Warriors. I mean,
Yeah.
that's so important.
Yeah.
And for many of these families are like that. They need support themselves,
Mm.
but they're also quite selfless in giving support to others as well.
That's the part that amazes me the most, is
Yeah.
how every parent I speak to doesn't just look at it through the lens of how it benefits them and their own child and their own situation. They're always looking at it from the community standpoint, right? To your point, Saquib. Yeah.
Yeah, very much. In fact, I was just having a conversation with a colleague about something different, somebody who's not familiar with this. And I said, the thing that you'll find with these families who have children with
Yeah.
rare diseases is that they are so dedicated to their child,
Mm.
and that can manifest in so many different ways.
Right.
They can be quietly dedicated and trying to, many of them have a lot of difficulties that they're trying to deal with in their own lives.
Yeah.
And they've got to care for this child who has a lot of needs, but they're so dedicated. And then some of them who have the opportunity and have the fortunate situation to be able to give, still take those steps and do give.
Yeah.
And it's amazing.
And to your point about the community, I don't know, I'm sure as you are helping and guiding parents navigating through this world, right? I'm sure there's a lot of emphasis for your perspective on the community in addition to everything that you provide them through your work at Cedars-Sinai.
Yeah, and a lot of that too is that we are as a I guess I'll use the word generic, as a generic rare disease program. I mean, we're not focused on any one
Correct.
condition,
Yeah.
right?
Right.
We're looking at it broadly, is that, a big part of what we do is diagnostics, and really sort of say, hey, look, hey, here's a diagnosis, so-and-so is the expert in this.
Right.
Here's who you need to be following up with. There's patient groups that we can sort of link you up with. So a part of it's to be a support, but really it's recognizing that, gosh, there's so many different things out there. We're focusing on trying to shorten the diagnostic odyssey, and then get them in the right directions.
Yeah. You mentioned the paper a minute ago, and I guess I have a two-part question about that.
Yeah.
One is, maybe you could just give us a little abstract on it for those that aren't familiar with it. But then secondly, you mentioned that it really was a group effort, right? So I'm curious as to some of the collaborations either within Cedars-Sinai or externally that kind of really helped advance, this topic.
Yeah. So we, the paper itself, as I sort of outlined a little bit earlier, but we started with the clinical description of looking at all these patients who have happened to have sequencing done and found 2 variants in the CRELD1 gene. And then we sort of noticed the common patterns in these children, including the seizures, the hypotonia or muscle weakness, some with the rhythm disturbances, and a few others. Some of them actually seem to have frequent infections. There's a possibility that CRELD1 might be related to immune function as well too. There's some papers on that too. So we started gathering this stuff together.
Right.
And then usually, typically when we're trying to define a novel disease that hasn't been described before, we want to have some other information beyond just the clinical and the genetics. But hey, can we actually find evidence that the patient versions of these proteins are not functioning normally, or that not having a functioning version of this protein actually causes something. So one of the tools that we use, and one of my probably my main area of interest is in disorders leading to seizures or developmental delay. And since this was associated with CRELD1, what we did was we use Xenopus frogs or tadpoles as a model. They're not mammals, but they're actually a great way to quickly screen for protein function. So what we did is we knocked the protein down in these frogs, meaning we sort of eliminated and asked the question, well, if you don't have functioning CRELD1, what happens to these tadpoles? And these tadpoles, they didn't develop spontaneous seizures, but when you induce seizures in them, they were way more susceptible than the normal tadpoles to seizures. So this kind of provides a link saying, okay, CRELD1 could be important for the development of seizures. And then the other thing that we did was that we, still using it, the tadpole models, is that we do something called overexpression, where we take the protein, the normal CRELD1 protein, and we put it in tadpoles, and we could see that we would have a craniofacial, so the head development would be off. Wow. And in fact, some of these tadpoles would even not develop at all. They would have early developmental defects. So that sort of it doesn't tell you much about normal function, but it says, hey, if you have too much CRELD1, you get these defects. Whereas the patient variants, so the variations in CRELD1 protein that we found in these patients, when you put those in the tadpoles, they didn't have as many defects. So what it says is it's not functioning as the normal protein should.
Right.
And so these are sort of additional pieces of evidence that sort of add to the clinical and the genetic work to sort of say, hey, these are important. So we did, a lot of that work was done. The tadpole frog work we did in our lab, along with my colleague, Dr. Mustafa Koka, who's also here with me at Cedars. So we did this actually when we were both at Yale before we moved to Cedars. So we did this over in the lab there. But having that clinical background was crucial.
Yeah.
So a lot of that information came, from careful phenotyping, from careful descriptions, from all the collaborating clinicians and researchers who were part of the paper. So and assembling that was a big task. We had a group from the group from NIH really helped us with that, along with GeneDx as well too. They were great facilitators as well. Sometimes we think about companies and having the bottom line as the main thing, but they were actually great collaborators with this, and we really appreciate them, along with all our other.
No, that's great to see that there was really the industry collaboration there as well.
Yeah.
Right? And that's amazing. So when you think about what you're kind of spending your current time on right now, is it more exploration into the seizure aspects of this, or what is kind of like your daily topic, I guess, or what are you chasing right now, I guess?
Yeah. So as we're largely concerned with diagnosing genetic conditions, actually what we've done is sort of establish some collaborations. There's Howard Goodkin, who is a colleague of mine. He's at the University of Virginia, and he's developing a mouse model to look at
moving it to mammal.
To get mammals. Frogs are great. They're inexpensive. They're super fast.
Right.
But mammals are a little bit better to study and ask some of the more human-based, human-oriented questions. So he's doing that. There's another collaborator in the UK, Felix Shen, who's he just recently moved to Birmingham, and he's also looking at some of the basic science aspects of CRELD1.
Yeah, I'm smiling because we're going to be talking to Felix soon.
Oh, you are.
Yeah.
So you'll be chatting with him.
Yeah.
So what we're largely doing right now is to help coordinate some of these efforts, make sure that, because people are reaching out to us with additional patients and asking questions about it, so we're trying to make sure that people have the support that they need, both through CRELD1 Warriors, and then also feeding into the additional basic science information. As our group here at we're moving on towards looking at additional genes and other different areas that we can look at to define additional diseases and conditions causing seizures in children. So we're really looking at how can we sort of establish these other conditions as well that are similar to CRELD1, and sort of give them a name, give them a diagnosis, and then move on to others. So we're really focused on the initial diagnosis aspects of it, and then making sure that people are moving to the right areas.
Which makes sense in the early detection piece that we kind of come
back
to.
Yeah, that really has been our focus.
Yeah. You mentioned a minute ago about you were pleasantly surprised. I don't want to put words in your mouth, but sort of pleasantly surprised in the industry aspect of the collaboration that you did in this particular, research project that you did. But from a broader, I guess, perspective of, the scientific community, the rare disease community working together to sort of accelerate research, if you, had the proverbial sort of magic wand, what do you think we could do there to kind of accelerate and have folks work better in these areas?
Yeah, that's always it's a tricky question, and usually the big challenge is both the way our research system is set up, both in this country and as well as abroad, is that it rewards discovery with more resources, right? So oftentimes it's a challenge because people want to be the first, and they want to be the one to do this, and so there hasn't always historically been a great willingness to share.
Yeah.
And I think these kinds of collaborations, but and that's what science is moving more and more towards. It's that collaborative effort, and there's got to be a willingness for people to share with what they have, and to recognize, hey, there's a lot to go around, and that we can all win. But then when resources need to be parsed out, we have to recognize that, hey, providing resources broadly is also important.
Right.
So I think, it's going to be, it's always a challenge to do that. I think we're becoming better. I am in a way, as a critical care physician, I am an outsider in a way to the genetics world. I tend to see that I think historically geneticists have not shared very well. Because the data has been, that's how you get publications.
That's your proprietary
your proprietary information. But now sequencing is becoming more and more common. it's really sort of moving beyond the sequencing into the basic science, and you've got to have people who have the skills to do that. So you really need that, both the sequencing, but let's share that, and then let's get the scientific work that needs to bolster the genetic work. And I think that's helping in a way.
Yeah. In terms of other advancements, beyond sequencing, do you see other applications you're also seeing, Saquib, about, AI or anything else in this space?
Yeah, I mean, there's still this is just an example, right? I mean, we have about 20,000 genes, roughly, plus or minus, in our encoded in our DNA, and yet, we probably know roughly about half of them. There's about 8,000 plus or minus disease-causing genes that have been recognized. So there's still a lot that needs to be done. Not all of them will lead to diseases, but there's still more that need to be discovered.
Right.
And then there's the genes are only about 1% of our genome, right? So there's about 99% that we still don't know what it means. I mean, there's some people who say that that's junk DNA, although I think it just means we don't know what it really does. And the more we discover about what it does, the more we say, these can actually lead to problems as well too. You can have variants in what we call non-coding regions of the DNA that can be important. They can control how certain proteins are expressed. You can have repeat regions that cause problems. You can be missing parts of some regions of DNA. So I think there is definitely a way, but you're looking at huge amounts of data, right? Yeah. Gigabytes of data for a single human genome. So clearly it's going to be important to develop these types of tools, and they are being developed. AI, machine learning, is that how can you analyze these large
giant data sets,
giant data sets, and start to make sense of them.
Yeah.
To start to figure out. We've already done a lot in the coding region. There's still stuff that needs to be done, but then you have this massive amount that's almost 100 times what we've worked on, and we're starting to piece together how those can affect both health and disease. So absolutely, there is a role, and that's underway, and it will continue to be important.
That's exciting. From a motivation standpoint, and going to kind of keeping pushing you forward in this field, especially when you're dealing with the complexities of rare diseases, is it these types of promising advances that push you forward? Is it, better public support for your research efforts? Is it the families? Is it all of the above? Like, what's really kind of helping you to continue to stay motivated and pushing forward?
It really is all of the above, but I'll tell you what ranks number one is the families.
Yeah.
Is really working with, the human beings, and it's kind of fun, in our rare disease program at Yale, we had a number of PhDs students or PhD, postdocs and grads who had not had the opportunity to really meet patients before and meet families, and they've been
mostly in the lab, and is that kind of why?
Right, because they're typically in the lab, and they're doing the basic science research, and they hear about it. Yeah, this came from a child, and here's this. But we've had some opportunities to have some of the families come and visit the program and to speak to them, and for them it was a game changer.
Yeah,
right? Yeah. And they're like, wow, this is, when I'm doing this, there is actually a physical child involved here. There's a family involved here. These are human beings, and that's just so motivational. And for me, I mean, I feel privileged that I can get that motivation all the time because I'm still in clinical practice, and I can still, almost every time I'm in the ICU, I see, there's definitely at least one or two kids in there who have rare diseases, typically genetic conditions, and I can see the impact that we're making. So yes, it's fun, it's exciting, the technologies are cool. It's a great time to be in genetics. But for me, the number one reason, it's the families and the really the blessing and the opportunity to be able to work with them.
And I have to think that this is kind of why you ended up where you are in the first place, right? I mean, look, pediatric care is challenging. Pediatric critical care is so challenging and so demanding. So if you didn't have a love for the impact that you're having on the families, I don't see how it would work, right?
Yeah.
Yeah, that is awesome. That is awesome. Well, thank you so much. Folks, we have been speaking with Dr. Saquib Lakhani from Cedars-Sinai, director of the Early Detection Program at Cedars-Sinai Guerin Children. Thank you for your time. Thank you for joining us today on Rare Awareness Radio and giving us more perspective on the work that you're doing around CRELD1. Thank you.
Thank you very much, Richard. Really appreciate you having me on.